So we're gonna write a program to print odd number using Java. Okay. So let's talk about algorithm first. And I'm going to write odd number between 1 to 100. Okay. 1 and 100. So how do we do that? So let's look at the algorithms, right? We said first algorithms, right? So we can use flowchart or pseudocode, right? If we do pseudocode, we said, okay, we're going to init, right? This is pseudocode, right? Initialize k equals to zero. And then we said, okay, after we initialize this, what do we are do use loop, right? While, right, k less than. So we gonna see if we say less than 50 first, and we just make it do this, do what? 2 times k plus 1. So you're going to pretty much just print this, right? Print 2 times k plus 1. Because when it is 0, then 2 times 0 is 0 plus 1, we get 1, right? Whereas 1, 2 times 1 plus 1, we get 3, and so on. And when it's reached to 49, right, it's keep doing that odd numbers until 49 is times to it 98 plus 1, which is 99. So all the odd numbers will print out. And then that's pretty much what we need to do by just do k plus plus, increment the k, right? So that's one way, using the math formula 2 times k plus 1. The second algorithm is same, initialize k equals to 0 and use the loop, right? But now we said, okay, we're going to do less than equals to 100. We can actually start from 1 because we look at between 1 to 100 in these scenarios. And then we, inside the loop, we just say, hey, if we take the values like k start from 1 and we look at the remainder, right? In Java, we just mod, right? Or we find the remainder. Okay. Right? Or we call mod. Okay. So k mod 2, okay? 2. So to find remainder. Alright, so if, okay, remainder happen to be what? Equals to 1. If it's equals to 1, that's odd number, right? So then we print k. Okay? And then it's pretty much done. If it's not, then we never print until it's exit the loop. So let's do that in Java now. Java, we're gonna write a code to do that. So we're gonna say int k equals to 0, right? While k less than 50. You see, it's easier if you do the algorithm first using pseudocode like we discussed, right? Because the list is just worry about syntax, right? 2 times k plus 1. So that should do. So we're going to write that. And let's compile this. Oh, we're missing k++ here. That's the last statement. K++. So now let's open another bash to compile this. So I use the first algorithm here, right? Export path equals to path, and we copy the location where you have your Java C, which is under JDK bin. Now we're going to compile, go into the folder CSC Java C to compile the while demo. Okay, now there's no errors, so we're gonna run it. Java while demo. So just print all the odd numbers from between 1 and 100, right? So that's when you use that logic. So now let's see, we want to use another algorithm. Let's take a look at the second algorithms here, how to write that, right? So I'm going to create another one called odd.java. So we're going to do public class odd and public statics void string args, and we're going to start to type a code. With the second algorithms, we're going to say int initialize k equals to 1 while, right, k less than. And you see the benefit of the loop here, you're repeating over and over again, right? 100. And you can just say if k, in Java mod is percentage, right, to get a remainder 2 equals to 1. So that means we found that is the odd number. Then we're going to print k. And let's say it's a good it's good to put a curve basis, right? Good practice. Alright, so we need to do k++ too afterward, right? Now k++ should not be inside the if, right? Should be outside. If it's inside, it will only increment for odd, right? So it should be like that. Alright, so now let's look at I'm gonna run this, compile the file name odd.java and odd. So we get the same result. Now the question is, which algorithm is more efficient? So when you take class in 202, when we talk about data structure, you have to talk about efficiency. How to measure the efficiency? We count instructions. Like we call big O as the unit. So this first algorithm is going to cost about n. N is the size. Like this is going to look 50 times. So it's about 50. Right? This one will cost about, so this is 50. So to loop, but this one will be 100 times to loop. Right. And this one will cost the CPU to do calculations. Right. This one you have to do k++2, right? To increment k. So this pretty much equivalent 1, 1. This is 2 operations. This also have to do that operations. Right. That do mod, compare, and do if, which is small operations. You may see that this one take a lot more work than this one. Okay, so this is more efficient way to write with the formula. But if you cannot think about formula, then it's okay to use this way. Okay, it's not much difference if we have small numbers. But if we talk about million of numbers, then you see the difference in the time to process. This should be faster, right? All right. That's how we use the loop while here, right? And we can do while and for too. It's technically do the same. Okay. So let's say, for example, if I modify this code to use for, what you need to do pretty much is, let's do first then. Just do, and move this down. That's the syntax, right? So the syntax is, you just, so I move the line down here, and this should be while, right? And do. So this is pretty much it. You just keep changing. Alright, change the syntax. And make sure you close it right here. Alright, so let's see if we're getting the same thing. And semicolon at the end. So I just write this file over. We're going to recompile this. Odd.java and run odd. So we get the same thing. So that's how you do while, right? Same thing with the other code should be the same. So let's say if I show you for. So we're going to change this to for, right? Now for, you're just combining the initialize part. Like I type 4 here in k, right, and the expression part like that inside, and put semicolon, and then we're gonna do the increment too. So increment pretty much is this one, which you can just select it, use V, right? V to just select, and D to cut. This is VI, and P to paste, right? It's just not exactly what they want. You just change a little bit. You may see the last semicolon is not necessary. So that's pretty much the syntax for for, and we just need to open the curly braces and close it. And that's it. So we go recompile this, and you see it's pretty much the same. Either while, do while, and for just give the same result. It just same result right there. It's just the syntax that's different.